So using Pythagoras theorem, if you know this dimension 10 and if you know this dimension, that is r minus 4, we can find out this radius, that is r minus 4 whole square plus 10 square will be equal to r square. Solving this, you will get what is r.
Yep.
So next we have to find out what is that angle theta. So we can say that sine theta is equal to opposite by hypotenuse. So from this we can find out what is theta. Theta is 43. That is, theta is the angle that is making. So if this is the dome and this is the axis, so theta is the angle which is making with this line. Next is we have to identify what are the loads that is coming on the dome. So we will assume that the thickness is 120 mm and load per meter square area, that is unit meter square area we are determining. So live load, it's 2 kilonewton per meter square. So we are assuming per meter 1 unit meter square, and finishes it is given as 0.5. So we will find out what is the corresponding units. That is 2 kilonewton. It is given as 2 kilonewton per meter square, and finishes is 0.5 kilonewton per meter square, and self weight is unit weight of concrete is 25 into what is the thickness, that is 0.12. So you will get 3 kilonewton per meter square, and the total weight will be the sum of 2.5 and 3. So you will get 5.5 kilonewton per meter square. That is the total UDL which is coming on this dome. Now in this question it is also told that there is a lantern at the crown of this dome, and the lantern is having a load of 20 kilonewton, point load of 20 kilonewton. So since we know that the equations for this meridional thrust and so we know that the hook force, meridional thrust and hook force corresponding to this point load will be at this crown portion will be infinity. So what we will do is we will assume that it is spread over certain region. So we will assume that this is being spread over a region of 4 meters. Say this is 4 meters. If this is a dome, the total span is 20 meters, and this is the center, or this is the axis. We'll assume that the lantern is being placed over this 4 meter span. So we can find out what is this, because since lantern is placed over, since we are assuming that lantern is placed over this complete 4 meters, the W, the weight that is coming over here should include the weight of the lantern as well. So we will find out what is the theta or what is beta angle. That is this the angle that this line, that is the line drawn from the center to this region where this lantern is kept with the axis. So we will find out what is beta. So beta, we will get it as, we know that this distance is 2 meters and this is the radius. So from that we can find out sine beta, and beta will be 7.93 degrees. So now we will find out what is the area of this lantern load. So as I told you, since those values were coming, hook values were coming infinity, we were spreading this lantern to certain distance. That is, here we have spreading it to 4 meters. So the area